Okay, so to wrap up this unit, let's take a look at what a stem plot is. The stem plot, the stem represents its value, and each leaf represents a data point. So look at our key here. In this situation, 3 with a line of 1 represents a 31-year-old in this choir. So stem plots of ages in church choir. Let's see, we have a 15-year-old, another 15-year-old, a 16-year-old, we have a 20-year-old, a 23-year-old, a 23-year-old, a 24-year-old. So in essence, the number on the left is in the tens place, and the number on the right is in the ones place. Okay? And also from a stem and leaf plot, what we can see is that this also can almost look like a sideways graph. So here we can see that this is about a symmetrical graph. Most of the data is concentrated in the middle of it. It's pretty much symmetrical. If we look at our second example, now we have a situation where it's length of worms caught, and our key says 6.2 represents 6.2 centimeters. So in this case, the number on the left is in the ones place, but the number on the right is in the tenths place. So we can see that one worm was 3 centimeters, 4.5. There were no worms that were in the 5 range. We can see that we had one worm that was 9.9 centimeters, and so on. Just like in the last problem, you can almost put a curve around it. If you were to flip this sideways, you would see that this would be skewed left. So stem and leaf plot, you have your stem that represents a certain part of it, and then you have your leaves that represent the data point. But what's an outlier? Okay, an outlier is any number way different than the rest. Now, this is not a mathematical definition that I'm giving you. This is just an explanation that makes sense to me. So think of it from this point of view. If we were to find the average height of everybody in our class, for the most part, we'd be, pretty similar. I'd be on the shorter end. We have a couple of students who'd be taller. But what would happen if someone like Shaquille O'Neal came in, someone who's super tall? I think he's 7 feet tall. He'd be considered an outlier because he is so much taller than everybody else that he would mess up the representation of the data. Okay, his super tallness would pull the mean closer to the high side. Okay, so it would skew the data. Okay, whereas the median, it wouldn't be affected because even if one more person showed up, the middle's still the middle. So explain the effect an outlier would have on the following. For the mean, you need to know that an outlier changes the mean, pulling it towards the outlier, whereas the median has no effect. Okay, let's look at another example. If we were looking at the average income of families in a certain community, okay, for the most part, communities are around the same. They make up approximately the same. But what would happen if a billionaire came into that community? All of a sudden, the average income would get pulled closer to the richer side because he has so much money. So that's just another example of an outlier and how it affects the average of things, but not necessarily the median.